Hello friends, today we will solve a problem on development of lateral surfaces. So here is the problem statement. A square pyramid of side 45 mm, altitude 70 mm, rests on HP with its base sides and two of the base sides are parallel to VP. The same problem statement is available in your VTU CAD drawing solution book in the page number 133. So this is the problem number 18. To construct the initial position, select rectangle command, cut continuous line 0.5 millimeter thickness. You can specify the width of 45, height is 45, angle is 0 degree. You can just place the object below the XY line. In the next step, change the line thickness, make it 0.13 millimeter. You can draw one diagonal to find out the center. We need to draw a diagonal and project thin projection line up to the XY line from the each end point. Then for the front view, select axis line 0.13 millimeter, length is 70, angle is 90. So specify the altitude of 70 millimeter and change the line type, make it continuous line and join it to the base edges and over here. In the next step, we need to identify the notation from both the front and top views. So we'll go through that. After projecting the notations, we need to identify the cutting plane. So in the problem, they given that the pyramid is cut by a section plane perpendicular to VP and inclined at 40 degree to HP, and the cutting plane bisecting the axis of the pyramid. So whenever they given the statement like the cutting plane bisecting the axis, we need to drawing a cutting plane line like the cutting plane intersecting over the axis line exactly at the midpoint. So select line command, axis line, 0.13 millimeter thickness, go to tools, Intel sketch, relationship, select midpoint and OK. Now we'll zoom this portion for our convenient. Okay. Now you can move the cursor on the center line. We are getting a midpoint symbol there. Left click, then you can specify the angle of 40 degree towards forward direction. In the next step, you can select extend to next command and extend a line towards backward direction. In the next step, you can select continuous line and 0.5 millimeter thickness. You can draw the border line by thin line. Okay, to differentiate this cutting plane line from the center line, we need to make this line by thick line, and the retaining portion of the object, the lower part below the cutting plane, should be drawn by thick line. In the next step, to project the exact distance of a cutting point in the top view, we need to draw a thin projection line over the top view. So from this endpoint here, just project a thin projection line. Select this endpoint and draw a vertical thin projection line. And don't forget to make this line by thin line. In the next step, we'll join all the cutting point by thick line of 0.5 millimeter. So before that, we'll mention the cutting point number 1 lies between A to O, and this is the cutting point number 2, the cutting point number 3, and this is the cutting point number 4. So select line command, continuous line 0.5 millimeter thickness, the cutting point number 1 to 2, draw a thick line, then 2 to 3, 3 to 4, then 4 to 1, and not to forget to join in these edges. In the next step, see here in this problem, you can see that the slant edges are all inclining toward the center of O1. None of these slant edges are parallel to the XY line. Whenever we are not getting the line which is parallel to the XY line, we are not getting a true length. So to obtain the true length from this endpoint here, point of intersection, so just you can draw a horizontal thin line. That should be a thin line of 0.13 millimeter. In case of the pyramid problem, it is very essential to project the true length for the development layout. So draw a horizontal line, select arc by center point command, continuous line 0.13 millimeter thickness, select this endpoint as a center and select the point B as a radius, you can cut an arc. Now select line command, extend this line towards upward direction and join it to the point O dash. See this thin line beside of this object, we can call it as true line. So because of the we are not having a line that's parallel to xy line, so we have drawn another separate line that is parallel to xy line to project true line. So now let's will shift all these cutting points over the true length line. So again, if you're not getting properly, we'll zoom that particular portion. From this cutting point number 2 dash or 3 dash, you can draw a line. So now we'll specify that particular dimension there. Select distance between command, select this endpoint and this endpoint, you can project. Sometimes it may not come. So such cases you have to select distance between 2 points. So that's 24.25 millimeter. Similarly, the distance of the cutting point number 2 and 3 from the XY line is 14.64, 46.61, and the distance of a true length is 76.89 millimeter. So in the next step, we'll go through the construction of a development layout. So we'll zoom this particular portion. Now you can select arc by center point command, continuous line 0.13 millimeter thickness. So left click anywhere here and specify the radius 76.89 millimeter. Now you can cut an arc. Okay, so select line command, continuous line 0.13 millimeter thickness. So from this endpoint up to the center, draw one thin line. Now you can select again arc by center point command. From this endpoint here, the distance between A to B is 45 millimeter. So specify that length 45 millimeter. You can cut an arc. In the next step, from the point O here, you can join it to this point of intersection. We'll join it to this a point of intersection, and you can join it to this lowermost endpoint here. In the next step, you can hold the control and select these 3 lines and select mirror command over here. You can mirror it. Square pyramid consisting of the 4 number of triangular surfaces. So you can trim that extra lines. So now with the help of a text command, you can take this as A and this is O and B. Okay. After drawing a layout, you need to mention the dimension for each side, and true length is 76.89 millimeter. In the next step, to project the cutting point number 1 to 4, you have to select arc by center point command. So the cutting point number 1 lies between A to A1 at a distance of 24.24 millimeter. So you can cut an arc. Again, the cutting point number 1 lies here with a distance of 24.25 millimeter. You can cut an arc. Similarly, the cutting point number 4 lies at the same distance, 24.25 millimeter. Cut an arc. Similarly, the cutting point number 2 and 3 lies at a distance of 46.61 millimeter. You can cut an arc for that length. Again, from the point C, for same distance of 46.61, you can cut one more arc. In the next step, we need to identify this notation here. In the next step, we need to join these cutting point number 1 to 2, 2 to 3, 3 to 4, then 4 to 1, again 1 to A to D, D to C, C to B, then B to A, and A to 1. Not to forget to join these 2 to B by thick line. The slant edges has to be joined by thick line because these are the integral part of an object. So that's it. This is the development for this given problem. Thank you. Thanks for watching.